Okay, so in this video, we are going to solve a question based on dynamics. So if you have a chance, you can pause the video, you try to solve it out, then you compare at the end. Before we start, do not forget to subscribe to our channel and share the videos and like for more videos coming. So this question goes like this. They're saying a body of mass 50 kg is pulled by a force of 250 newtons along a rough horizontal surface. The coefficient of kinetic friction between the body and the surface is 0.48. So they're saying find the acceleration. All right. So in physics, the best thing to do if you want to understand the question in an easy way is to do what to draw what we call the free body diagram. Is to sketch what we call a free body diagram. By the way, free body diagram simply means a diagram which indicates all the external forces that act on a given object. So this is a box which is having a mass of 50 kg. So since it is resting, or maybe it is moving along the horizontal surface with a force which is given as 250 newtons, somewhere there, then the friction force has to be pointing in the opposite. Remember, under dynamics, we are not allowed to be uh, drawing the forces towards the object. Every force has to be pointing away from the object. So this is going to be my friction. In this case, they have given us the coefficient of kinetic friction. So here I'll say friction, I'll put a K down. All right. Then if we proceed, we understand that it also acts, it also produces a weight which is called mg, and also the force which is being produced by the surface has to be called a normal force. So these are the forces that act on the object. So here we understand to say the object is moving towards the right hand side with the force which is given something like this. So in the here we are going to have two axes. We'll have the y-axis and also the x-axis. So since the force which is this one is along the x-axis and makes the object to start moving, meaning that I'll say the summation of forces in x must be equal to acceleration, which is m. So the forces in y, they're not moving. We are saying the forces in y, they must give us 0, meaning that they're balanced, they're equal. This actually simply means the normal force is going to be equal to the weight force. So if we check the acceleration, the summation of forces in x is going to be the addition of this force which is moving towards the positive minus the one which is moving towards the negative as the opposing force, and we are going to have something like this. I'll say 250 minus friction, which is kinetic, giving us mass multiplied by acceleration. Remember, they want us to calculate for the acceleration. I'll divide throughout by mass, also divide throughout by mass, even on the left hand side. Okay, so what are we going to do on the part of friction? We understand that there is something which relates friction and the normal force. What is that? That is what we call coefficient of friction. So you find that mostly friction force is given by this formula, say mu, which is coefficient of friction. In this case, we are dealing with kinetic output K, and I'll say the normal force. So here we are saying normal force is equal to, sorry, this has to be G. Okay, normal force has to be equal to mg, which is the weight, meaning that we are going to have friction force given as something like this. So I'll get, or just calculate from here. I'll say friction has to be equal to what value do we have on the part of coefficient of kinetic friction. They have given us this value, which is here as the coefficient of kinetic friction. The mass is that one. G has to be taken to be 9.8. So we are going to have 0.48 multiplied by 50 multiplied by 9.8. So meaning that friction is going to be equal to, we need to punch this on the calculator for us to get the accurate answer. All right. So here I'll say, here is my smart calculator. Very, very, very smart. So we have 50 multiplied by 0.48 multiplied by 9.8. So we are getting the friction as 235.2, meaning that that's what we are going to put where there is friction. We're going to have 250 minus 235.2. Divide this by what is the mass. We are saying the mass has to be 50, giving us the acceleration of the box, meaning that acceleration here is going to be considered to be, okay, so I'll say 250 minus 235.2, then I'll divide this whole thing by 50, and I'm getting the acceleration as 0.30 meters per second square. This is how we handle this question. Let's try to solve another question apart from this. Let's try to solve another type of a question apart from this. We proceed. This question is saying a constant force of 100 newtons is applied to an object or to a 10 kg box at an angle of 30 degrees above the horizontal as shown in the figure below. All right. The frictional force of 7.5 newton acts on the box. If the box starts from rest, how far will it have traveled after 5 seconds? They have given us a certain information here. So, like I said, drawing a free body diagram is always important. Drawing a free body diagram always gives an importance on our side. What does it mean if they say a force has been applied at a given angle? Initially, the object can be at this given position. What they mean by saying the force is being applied at a given angle, they mean something like this. Its angle with the horizontal has to be 30 degrees. So remember, since the force has been raised at a given angle, it is neither parallel nor perpendicular to make the object move. Under the law of Sir Isaac Newton, which is the second law of motion, we are saying the applied force has to be directly proportional to the acceleration, and it takes the direction of the force. The object must be taking the direction of the force. It can't move at an angle again, hence it must move in this given direction. So this is going to be 100 newtons. It can move and cover a certain displacement, then it is going to locate itself at this given position. So the distance covered here is going to be noted as S. All right. Okay, so what we are going to understand is, if we come to this one, the friction force has already been given as the opposing force. But if I'm to check, I don't exactly know what force makes it move in the horizontal direction. Meaning that the force in this case, we know that all the forces are vector quantities. So I'm going to resolve that force into its component and choose the one which is parallel to the displacement, which is this displacement or the horizontal surface. So we're going to have 100 newtons here, then my 30 newtons. So this is going to be resolved into 2. We are going to have 100 sine 30 here for the y component, then x component must have 100 cos 30 in this given direction. Remember, I'm saying the force here, which is going to make this one move in the horizontal displacement or direction, has to be the one which is what? Parallel to the what? To the displacement. In this case, has to be the component which is the horizontal component, meaning that the force we're going to consider here has to be this one. So I'll say summation of forces in X must give us acceleration. First of all, we need to find what we call acceleration. Find acceleration, that's when you can do what? That's when you can find the actual distance we are going to have for it to cover that same displacement. So here, remember I'm saying this has to be the force which is making it move forward. But remember there is a friction force pointing like this. This is 7.5 newtons. If you want, you can even do it like this, normal, then weight mg, but these are not important. Reason being, we've been given the friction force already. Unless if we were not to be given a friction force, I would have resolved it into, I would have done it like the way we are doing here, using the same formula which is here. But you have to be careful, because normal force for such kind of diagrams can't be equal to mg. Reason being, we have another component which is also facing upwards. In this case, the summation of upward forces must be equal to the summation of downward forces. All right, we proceed. So we are going to have 100 cos 30 minus the opposing force, which is 7.5, equal to mass multiplied by acceleration. I'll divide by m. I'll also divide by m. I'll cancel this. Acceleration is going to be equal to, if we try to punch the top part like this using my smart calculator, we are going to have 100 cos 30, say minus 7.5. We are getting that. If we divide this answer by the mass of the box, which is 10 kg, so say answer divide by 10, we are getting 7.91 as our acceleration. So we are going to have an acceleration of 7.91 meters per second square. Just a bit, I want to get back to the question itself. This question is telling us to say it started from rest, meaning that the initial velocity in this case has to be considered to be 0. All right, we also have 5 seconds. We've diverged to what we call kinematics. We have 3 important equations that mostly helps us find the unknown variables. These are the equations that we are going to pick one of them and use it. So which one do you think is applicable at this moment of time? Look at the information given. No initial velocity is given because it started from rest. We have the acceleration, we have the time. Definitely, don't worry, this qualifies to be the formula that we are going to use. I'll say S has to be equal to, this one is going to be cancelled because initial velocity is 0. Then we are going to have 1 over 2 multiplied by 7.91 multiplied by 5 square, and the distance that the object is going to cover is going to be calculated like 7.91 multiplied by 5 square. Now divide this by 2 and we are getting 98.88. 98 point, just write like this, 0.9 to be the distance the object is going to cover. Alright, I'll drop my email at the end of this same video. If you want, you can forward any question based on the same topic so that we can help it out and see the best way we can move. Thank you for watching. Thank you once more.